So I know you want to see this. I mean, wood's one thing, right? But this rigid foam that I have really gives us a very good perspective of the quality of the cut. Now, it is foam, okay? But it shows you the damn thing is not doing too bad. I don't know what's going on with the dimensions. I'm going to have to check them. They might be okay. They might be off. I've put in a width and height, and what I'm seeing here, width and height, is altogether different from anything else. So, I mean, the diagram looks like it's right, but I tried to stack the short piece that I need to cut. So I cut the short piece and then the long piece. It doesn't seem to do that. It just does the full cut no matter where you are. So I'm not sure why, but that's that. And the, oh, there's the light. I thought I had my light on. You can see it's a really crisp edge, straight edge. Notice, oh, you can't really tell, but that screw is working just brilliant. I think it's brilliant. It's just very straight, not much. There's some wobble on this end, but I've got a hunch when I look at it, it looks like the coupler is walking in kind of odd. So I'm going to get a new one and try to refit the new one a little straighter. Plus I'm going to beef up this joint, as I told you in the last video, beef up this joint down here. But I just couldn't wait to get a cut going, you know. I just wanted to see what I'm going to have and check it against what I need. This is pretty good. I just happened to find this piece of foam I had left over from, I build train tables out of this for people. I make a 4x4 train table, and when I give trains away or sell them as a small set for startups, you know, I use 4 pieces of this, glue it together, put it on a little base, and that way they can shove it in the closet or under a bed or something. Then when they want it, I pull it out and the track's all mounted and everything. It's really cool. But in any case, this is taking, I think it's a 0.5 millimeter cut, and you can see, well, of course, foam, right? But even with the metal, I don't think it's going to be that big a deal. I think it's going to be okay. I think it's going to be okay. I'm optimistic, of course. But you see how I have it doing? It's making an inside-out slice, and it's taking 1.5 millimeters, so it's a 1/2 of a tool width cut to go to the full width, the full dimension. Now, this looks big to me. The length looks right, but the width looks like, I don't know that I need that much width, but I gotta check. Maybe the newer devices have a bigger slot than I need. I don't know. In fact, this slot doesn't look long enough for the other reason. It's supposed to be a 10x18, so we'll check it when I get done here. I'm not going to be done for a while, I can tell you that. This thing goes down quite a bit. At 0.5 millimeter at a time, it's going to take a while. So I may just cut it short, take my measurements, and see what I got. Well, boy, does this give you a great idea of what you can do with a DIY mini mill. Boy. Yeah. I mean, there's things you have to be careful when you're putting it together, you know, making it square, getting the right parts all the time, and being careful how you assemble and design your end stops and whatnot, and your limit switches and your brackets. Everything has to be hard mounted, very nice. And your cabling. I still need a box for my board over there. I'm sure I'm going to fry it here shortly. Boy, this is really, really neat. I can get a gear, you know, and test fit the gear. That would be the real test, but I need to find out. I guess I'm going to do the dimensions, and I'll show you the differences. When it comes up to change the tool depth here, I'll stop it and show you what I got. Boy, is that a nice cut. Oh my God, you should see me trying to hog this out manually. Rotating the thing, faster, slower, goofing up, you know, going too far, not far enough, rough edge, you know, just awful, just awful. This is going to be outstanding. Okay, he's pulling up, so I'm going to call it stop. Call it a stop. I forgot, it doesn't turn the spindle off. Oh my God, okay. I'm going to go to jog control, and I'm going to pull the Z up. I want to show you. There's the, this is the, I don't know which is which now. I think this is the part, so we're down 2.5, or what we were, I don't know anything, okay? But one's the part and one's the tool, the machine. I think the bigger number is the machine because it has all the range of motion, right? This is the top one is the part. Where have I been on the part? Okay, so I'm going to raise this up. And I did, in order to get to my full depth, I had to lower the tool on that big bar, the old Dremel lift bar, and it allows, it's made that way. I kept it that way. And one thing that's a little concerning is it doesn't maintain square. I don't have a mechanism to do that. So when I rotate, when I lower it and raise it, if I rotate it on that bar, I got to double check it when I go to put it back on. Square it up. I got to have a tool to do that. I really do. Any case, I'm going to jog this up almost to the top. Okay, that's probably far enough. Let's see what we got. Let's just check it right here. You guys can see it when I see it. How's that? Or at least I'll tell you what it is when I see it. Okay, we're zeroed. Something's in my way here, of course. Well, let's get the width and see if I can get that. Oh, yeah, I can get that. 1127. 1127, that doesn't sound good. Now, you got to be careful because you can deform that foam and get a bigger number. 1120, 1127. What? 18, 10, 18. So it's 11 is supposed to be 10. That would tell me that is a calibration error, which one of you guys wrote me about and thought I needed to recalibrate, and you're absolutely right. That's a calibration problem on the y-axis, I'm thinking. But look at this now. This is 10. This is in the factory one. My gear is not that fat, so I don't need to take a cut 10, okay? And if I do, you know, that's all the meat I have. So by golly, I better have that 10, you know, pretty close to dead center, or I'm going to be in trouble. This part here is real thin. This one's real thick, so I wouldn't want to do that. I'd like it to be dead center. There's room in here for other things. This is not a real, this was not designed for what I'm doing. And my gear hangs down on plastic. Well, I kind of have one right here. Oh, my gear is thick, isn't it? Look at that. Boy, it does come right out to that side edge, doesn't it? Oh, damn it. Oh, this is in the, this is not, this is one where I've put my gear on the bracket already. Okay, I've got another one where my gear hangs down on its own. That's the one I need to see. I have to dig it up and find it. And then I can make sure I'm not going too far. But 11.2 is 1.2 over, okay? So let's get this off and let's see what the length is here. It doesn't sound right. Oh, it looks nice. That's a heck of a nice notch there. Okay, here we go. Don't squish the foam now. This, get out of there. 18.8. Well, that would make sense. 18.8 and 11.2, and it's supposed to be 10 by 18. So, all right, Houston, we got a problem. Calibration. All right, well, let's see, what time is it? 10 to 5. I asked for 5:30 and she gave it to me. I can do a calibration. Yeah, I got time. Okay, I'm going to calibrate it one last time and just see what I can tune it to. Tune it tight, you might say, and then try another cut. Move it around, try another cut. Okay, but there's the cut. That's a cut, right? That's what this is going to do. And boy, is that pretty. My God, it's a simple slot, right? It's all it is, a slot for a gear. But boy, when you have been hacking around like I have, and you can do that. See now, if you look at the squareness of the part and the squareness of the slot, you can see the slot is cockeyed like that. You can see it, right? So I think that's a sign of my tool is not square. So I got to check that. I get so excited about seeing it do stuff. I haven't really done all my calibrations like I'm supposed to have. But the comparison here is, well, I don't know. It does look wide enough. It does look wide enough. Because you're saying you only stick the gear down. You only need that much room to stick the gear down, and I've got more. See? Wow. Okay, well, I'll have to get my new piece, figure it out. I got one around here. I built several of them, and it was so hard for me to grind this out. I just didn't use that many, and that's why now I want to do it. I want to be able to grind this out, but boy, oh boy, just imagine if that slot was in there where it's supposed to be, you know, like just a little bit behind that. That would just be perfect. It would just be perfect, and my gear would just hang down and would be driven. And when my gear hangs down, you can see that I have a limit switch on this side. Maybe you can't. Oh, I don't have my light on. Oh, I hit the wrong button. Oh, what's all this stuff? I was looking for these buttons. What are they doing up there? All right. Ha! Okay, there's a limit switch there and a limit switch there, and this gear has a cam on it. Oh, that's why it's a thick gear. It has a cam. I may need that with. Okay. So this triggers, one triggers a puff of smoke, puff, puff, puff. The other one triggers a chuff sound. That's the steam exhaust. Shoo, shoo, shoo. So you got puff and chuff. This is the control board for the puff and chuff. That's the control board for the smoke temperature. This is well, there was a motor control board. I stole it. I got new ones. That's a motor control board goes there. These are volt regulators. This is the sensor. Is it? No, that's just the power. Oh, that's the soundboard. Down inside there is a soundboard, real skinny soundboard. So that's the chuff sound. There's the speaker. Ha ha, I got it now. Ah, and I remember this one, when you idle, like at your station, it has a slow speed, no chuff sound, but the smoke will come out like a lazy smoke. Yeah, I haven't played with my damn train so long, I forgot. Look at all these buttons. I've been looking for these buttons, and they were stuck to that permanent magnet field. Oh boy. Oh yeah, I got to get back to this too. Oh my God. This is my wireless handheld controller. I'm supposed to be fixing that up. Poor Margaret got sick. I just had to let go of a lot of things. She's much better. Not really sick. She did get sick. She broke her foot, but then she got sick on top of it. It's just been a mess. That's a controller board that goes there. My whole hobby is trains, right? That's what I do. I love to build these trains. I got them all over the place, and my train layout's way over there. And I got engines on shelves and engines in boxes. But I wanted to make this engine have puff and chuff, and I couldn't do it. I had to grind that out, and when I ground it out, it was just a pain in the butt. So I bought this thing. I did it by hand. It was a pain in the butt. I got this thing, and it helped. But what I need is a mill. I need a real CNC. So see how the whole thing just sort of snowballs into, why are you doing this? And then now you're, okay. That's the story. All right. At any rate, I feel very good with the progress. I feel very good with the progress. I feel very good with my cut. Now, I've cut with this very tool, okay, manually. I cranked these things and brought it down and cranked some more and brought it down, and I was able to mill it out, okay? So I know this all will work. I just needed to get repeatability and get the manual part out of it. If I can clamp one in a fixture and say go, knowing I'm going to get the slot I need, that's going to be awesome. That's going to be just awesome. And then this, of course, could lead to other parts if I want to do some castings and then I need the machine detail or something like that, or 3D print and then the machine detail. That's another thing. So, oh boy, what a treat. Okay, that's it. I got to go. I'm going to go calibrate this thing. Thanks. Bye.